So we are almost finished looking at this document now. Before we move on to the next one, there's some prefixing considerations. The IPv6 specification prescribes a /64 prefix length for the normal IPv6 unicast address. Because there's a very large address space available for IPv6, you may want to use a different prefix length than a /64. A prefix length other than /64 in IPv6 will break the operation of the following technologies: neighborhood discovery, secure neighborhood discovery or send, privacy extensions, parts of mobile IPv6, and protocol independent multicast sparse mode or PIM-SM with embedded RP. Site multi-homing by IPv6 intermediation. The /64 prefix, the 64-bit prefix, should be used for the traditional LAN and WAN interfaces of network devices. The /126 prefix is typically used for point-to-point links that are similar to IPv6 address conservative as /30 allocation for point-to-point links. However, the addressing space in IPv6 is a lot larger. The general recommendation is to use the /64 on a point-to-point link as well. The /127 prefix, the equivalent of a /31 on the IPv4 point-to-point. But again, for simplicity, you should still consider using the /64 prefix. And we have 128 as well. The 128-bit prefix may be used in those situations where one address is required. For example of this type of address is the loopback address of a network device. IPv6 address space assignments for internet connectivity. IPv6 isn't very different from IPv4 in that sense. For a company to connect their internet using IPv6 addresses, it must acquire a block of IPv6 addresses from the routable internet space. IPv6 address blocks are distributed just as IPv4 blocks are, with one exception, is that IPv6 blocks are either local or a region or global. So provider assigned address spaces isn't portable between service providers, and it stays in the service provider's region. The service provider may include provider assigned addresses as part of the service unless the service itself is multi-homed. PA address space is sufficient. If a company is multi-homed, it should procure provider independent address space from its regional internet registry. Different registries have different policies and cost structures relating to PI address spaces. So dual stack. Dual stack is the basic strategy to use for large agencies that are adopting IPv6. It involves configuration of devices to be able to run IPv4 and IPv6 simultaneously. IPv4 communication uses the ordinary IPv4 protocol stack, and IPv6 communication uses the IPv6 protocol stack. An application choose between IPv4 and 6 based on the response to DNS requests. The application selects the correct addresses based on the type of IP traffic, because dual stack allows hosts to simultaneously reach existing IPv4 content and IPv6 content as it becomes available. Dual stack offers a flexible adoption strategy. However, because IPv4 addresses are still required, dual stack isn't a long-term solution to address exhaustion. Dual stack also avoids the need to translate between protocol stacks. Translation is a valid adoption mechanism, but it introduces operational complexity and lower performance. Probably should read this as well. Because a host automatically selects the right transport to reach its destination based on DNS information, there shouldn't be the need to translate between IPv6 host and an IPv4 host. So tunneling. Tunneling encapsulates IPv6 traffic within IPv4 packets and are primarily used for communication between IPv6 or dual stack sites for connection to remote IPv6 networks or hosts over an IPv4 backbone. So there's obviously many different kinds of tunneling, including 6-to-4, ISA tap, Teredo, 6PE, 6VPE, and MGRE v6 over v4. Tunnels may be manually configured or automatically configured. Most modern operating systems include support for tunneling in addition to dual stack. Address family translation, or AFT, is the process of translating addresses from one address family to another. During the adoption phase, AFT is primarily used to translate between IPv6 and v4 content. AFT may be stateless, where reserved portions of v6 addresses are automatically mapped to IPv4, or it may be stateful. So pilots and trials depending on the specific requirements, and here's an example of the below in figure 6. IP network of the data center, ATF for public web presence, an IP network such as a campus would use dual stack, a WAN, site-to-site, IPv6 over v4 tunnels, and remote access hosts initiated tunnels. So this is how you should really implement a guide, but this is the end of the guide, thankfully. So we'll have a look now at some easy implementation techniques for IPv6. So next we're just going to take a look at some practical steps for enabling and implementing IPv6. Again, this is another Cisco document, so it's got to be a good one. So we've got IPv6 adoption drivers here. It can be government mandates, connectivity to mobile devices, and the rapid increase, which means that there's far more of them than we ever expected, far more than IPv4 can cope with. Business partner connectivity. Just because we haven't adopted IPv6 doesn't mean our partners haven't, and if they request work from us, or if we are providing products to them, then we need to make sure that our products and our network and our systems are IPv6 compatible as well, so we can interact with our customers. Theatre. No more IPv4 addresses available. We're kind of forced to move over to IPv6 really. We've done everything we can, from selling old addresses to ensuring that new ones are limited and rationed, and it's still not enough. IPv4 is running out. In increasing IPv6 content, a lot of websites and a lot of networks now, I guess, run IPv6, and we need to be able to integrate into that, so we need IPv6 ourselves. So, the world has changed. July 6, 2012, IPv6 was first implemented. So there's 80% of the IPv4 addresses are used, and these are the companies that use them here. And so the content, less than 40%, is Google, Facebook, Yahoo, Bing, Wikipedia, Netflix, Amazon, 1,000 enterprises and public agencies. So when the tree falls, we can hear it. When the forest grows, not a sound. So basically that's almost saying as soon as IPv4 runs out, everybody's going to scream, but nobody really knows about IPv6 and its kind of growing popularity. So IPv6 adoption in the major US ISP, Verizon, has adopted 31% of its original scope up to IPv6. The same for AT&T, which is 11, and Comcast is 2.5. So countries between 10 and 3% are Switzerland, Romania, France, Luxembourg, Germany, Belgium, Japan, and the USA. So as far as forecasting goes, we're hoping that 90% of countries will have adopted it by 2021. And let's go straight down to deploying. So enterprise deployment options. Outside in, which is internet evolution, business continuity, B2C and B2B. Or inside out, which is globalization, technology leadership, industry mandate, BYOD, security visibility, and flattened management plane. So the planning steps, this is where it starts to get important. You need to be able to evaluate the effect on the business model when you implement IPv6. You need to establish an IPv6 project management team, because somebody needs to have eyes on this from a responsibility point of view. And if something's going to go wrong, or if something is going to need a lot of management, then this kind of responsibility needs to lie with a particular team, rather than just saying, oh yes, we're going to implement v6 now. You need to be able to say that you have a team in place that's managing it. They can be your point of call and your IPv6 experts. You need to assess the networking hardware and software. What do you have already? Is it going to be IPv6 capable? IPv6 training strategy. It's not as simple as we first thought. It is simple when you know how, but then again, so is binary, and from the outside it's just big and scary. So you need to put some training in place for the guys going to be using IPv6, just to make sure that they have the knowledge and the capability to deal with it on a day-to-day basis. And obtain IPv6 prefixes and develop an address plan. From your IP address provider, you need to obtain a prefix. You need to define IPv6 architectural solutions and get it approved by senior management. You need to test application software and services to make sure it's going to be compliant and compatible with v6. Develop a security policy in line with v6. It's going to change drastically from v4. You need to develop a procurement plan and develop an IPv6 exception strategy. So IPv6 addresses can be allocated in 3 ways. A provider assigned address, a PA address, addresses and prefixes assigned from prefix pool, assigned to service provider, and PA provides prefixes and route aggregation, and change between SP would require renumbering, and internet routing table size is minimized. It can be provider independent, addresses and prefixes assigned to subscribers independent of the provider pool. You can also have a unique local address, which is address and prefix assigned to subscribers for local communications only, and it's not routable onto the internet. What type of address should you actually use? So the recommended approach is to have a global only PI or PA address, which is an old school security folk that believes topology hiding is essential to security. Will definitely bark at this option because it's kind of opening up your network topology to the internet. A unique local address, a globally unique prefix with high probability of uniqueness. We can have a unique local address, which allows for the best of both worlds but at a cost. Much more address management with DHCP, DNS routing and security. And source address selection, or SAS, doesn't always work as it should.